This is the second set of problems from today. These ones are all looking at multiplication and division with fractions. So for these ones, we do not need a common denominator. We can just multiply straight across, and with division, our rule was flip whatever fraction you are dividing by, and then multiply what you get. So here, the temptation is to just begin multiplying straight across and saying that 12 times 14 is 168, so I've got 168, and x times x is x squared, and then flip this over and it'll be z over 2x, so we've got z, and then in the denominator I have 7 times 3 times 2 is 42, and z squared times x. And that's fine, but then afterward you have to go back and start simplifying, and you could say, well, I have a z here and a z squared. So z squared is z times z. One of the z's is going to cancel. X squared is x times x. One of the x's is going to cancel. And then we continue, and the question here is, what is 168 over 42? So we can start working that out. We've got an x left on the top and 42z left in the denominator. I know I can divide them both by 2, and I would get 84 over 21, x and z, and I could divide them both by, it looks like 3. And 84 divided by 3 would be 28. 21 divided by 3 is 7. And then both of these you can divide by 7. You get 4x over z. And that's 100% fine. There's nothing wrong with it. It gets you the right answer. There's another way we talked about doing the problem in class as well. And that would be to first, before multiplying, try to simplify by reducing at the beginning rather than waiting till we have our product at the end. So we can start looking for something on the top and the bottom. So 1, notice that I've already flipped my second fraction, and I'm going to multiply. We're looking for something that is on the numerator and something on the denominator that can cancel. When you multiply these fractions, we can put them all into one big fraction, where these are all multiplying. And I notice that I have an x on the top and an x on the bottom. Those are gone. X divided by x is 1. Z squared on the bottom and a z on the top. You know that's z times z, so you can cancel out one of the z's, which means that it's no longer squared. It's just z. And that's it for the variables. But now we can start reducing other places. So for example, 7 and 14. I know I can divide 7 by 7 and get 1, and 14 by 7 and get 2. I can divide 12 and 3 by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. And I can divide 2 and 4. 4 divided by 2 is 2. 2 divided by 2 is 1. And look at what remains. So I'm left with a 2 and a 2 and an x in the numerator. 2 times 2 is 4 times x, and in the denominator everything is a 1 except for the z. And we can check back. This answer and our answer here are the same. It's up to you to decide which way you like better. In general, the second way that we did it will usually save you time, but it will not always. This is an example where it definitely is going to save you time. So you could start trying to distribute, and then you could take whatever you get from there and begin distributing to get a cubic, of an x times an x, and it's not worth it. Instead, what we'd like to do is recognize that we have some things in the numerator and denominator that are the same. And because everything is multiplying, we're allowed to reduce those items. So there's an x plus 3 and an x plus 3. One on the top, one on the bottom. It doesn't matter if they're coming from different fractions or different sides of the fraction, as long as it's all multiplication within the fraction. And I can cancel out my x minus 4 and my x minus 4, and I'm left with x plus 2 over x plus 3, which you don't really need the parentheses because they're just alone on the top and bottom in the fraction. question 3, we want to think about our order of operations. And we have parentheses, exponents, multiplication, division, addition, subtraction. So first thing, let's work on the parentheses. I want to try to put that all together into one fraction. So to do that, we're going to get a common denominator. I need to multiply by 4y to this fraction and x to this fraction. I get 12y over 4xy plus 5x, because we were multiplying by x, over 4xy, which becomes 12y plus 5x over 4xy divided by xy. And remember, division turns into multiplication if you flip the fraction. So you have 12y plus 5x, 4xy, times y over x. And now all we need to do is distribute. So we get 12y times y is y squared, plus 5xy all over 4x squared y. The last thing we can do here is look to reduce. Every single term in the fraction has a y. So what we can do is actually divide by y. And what that means to me is that earlier in the problem, specifically in this step, I could have done something to save myself some time. So notice, if we think about multiplication, instead of just distributing, we've got two fractions that are multiplying. We have a y in the numerator and a y in the denominator. And this term here is just multiplying by our y. So we have y and a y, they cancel. And what we really could have had is just 12y plus 5x over 4x squared. Our last problem is similar to some of the others. The difference here is that we have this quadratic problem at the bottom of one of our fractions in the denominator of the first one. So the very first thing we're going to do, as the hint says, is to factor that quadratic. So everything else remains the same. I'm going to write it all together in one fraction, times 9x plus 1. And this quadratic, looking for things that multiply to 10 and add to 7, spend a little time working on it, you'll see that it's x plus 5 and x plus 2. And I can start multiplying, but the first thing I want to look to do, since these are all terms that are multiplying each other, is there something in the numerator and denominator that is the same? There's two things here. One, I have an x plus 5. Those are gone. I can replace them with 1 if I would like to show what the division was. Also, a 3 and a 9. I know I can divide 3 by 3 and get 1, and 9 by 3 and get 3. So what's left? Well, there was a 4. There was an x minus 1. That's all that's in the top. And on the bottom, the denominator, we have the 3, an x plus 2, and an x plus 1. If you really wanted to, you could distribute, and you could get 4x minus 4, and you could get 3x squared plus 9x plus 6. Personally, I think the one on the left is a little bit easier.